by now, most of you are familiar with what Zupass is. You will have used it to check in for this event. And I can see some of you have collected some frog hats, so you've been playing frog crypto. So you're kind of basically familiar with what Zupass is. Originally, I had a slide here where I was going to talk about, Zupass is a kind of zero-knowledge data manager for your personal cryptographic secrets and that kind of thing. But I think it's just easier to talk about some of the things you can use Zupass for. So we have here ETH Berlin, the voting for the hackathon. So you prove that you're an attendee at ETH Berlin. And you can anonymously vote for the winner of the hackathon. And that was used to award prizes. You used it to check in at Devcon. You used it to play Frog Crypto, and you won some Frog merch. Maybe you were at DevConnect, and you sent anonymous messages to the Telegram group by proving that you were a ticket holder. And then the bot would anonymously send your message. If you're at ZooConnect, you might have participated in a distributed clinical trial using a data gathering device that would then store that data and then anonymously prove that you participated in the trial when you submit it. Maybe you were at Edge Esmeralda and you participated in the Run Club using Strava, and you were able to compete anonymously with other people to see who could cover the most miles. Maybe you voted in the quadratic funding round for the Zuzulu community, and again, you will have used Zupass to prove that you are a member of the Zuzulu ecosystem, that you had attended previous events. And here at DevCon, you might have also participated in the speaker Q&A. So again, you're proving that you're an attendee of the event and then participating by creating questions and getting answers from the speakers. So Zupass is basically all of these things. It enables all of these things to happen. And I kind of want to give a bit of a philosophical reason for why Zupass does things the way that it does. So rather than going into how it works, if you're interested in how it works, we're doing a CLS on that tomorrow. But if you want to know why ZK and why decentralized data, this is a sort of philosophical background. So there's this concept called conviviality, and conviviality means living together. It's from the Latin, con and vive means together living. And it kind of connotes this idea that we create our lives together. We collaborate in creating the meanings that our lives are made up from. And this book by Ivan Illich, I think written in the 70s, applies this view to technology. So he has this idea of tools for conviviality, where a convivial tool is something where the user of that tool is empowered to find their own use for it. The tool doesn't tell them what to do. It gives them options, and they figure out what those options mean and how they want to make use of them. So we regard Zupass as being, in that sense, a tool for conviviality. It's a tool that doesn't tell you who you are or what it means to be a person. It's a tool that lets you collect data and decide within your community what that data means. So there's a bunch of philosophers throughout history who've thought about this stuff. Two of my favorites are Alistair McIntyre and Michael Walzer. McIntyre thought about this question. He wrote a book called Whose Justice, Which Rationality? Which again was on this question of meanings. Like, what does it mean for something? Who gets to decide the rules of what things mean and what actions are possible? What exists? What's real? And his view was that different traditions do this in a way that is kind of sort of incommensurable. Meaning that you can't have one system that incorporates all traditions. Every tradition has its own notion of what constitutes truth, goodness, beauty, and they need to find their own representations for those things. Similarly, in spheres of justice, Michael Walzer makes this defense of pluralism and equality, and he's arguing against a view of kind of egalitarianism where what's fair is that everybody has the same thing, and instead he's saying, like, what's fair is that everybody is part of a community that gets to determine its own sense of what's valuable and its own sense of what's good. So instead of being put in a single global hierarchy, you have many different hierarchies, and people get to have a leading role in their own kind of smaller community. And then finally, just two more references. So one is The Society of the Spectacle by Guy Debord, written in the 60s. And he talked a lot about this concept of order givers and order takers, and how society is divided into people who tell other people what to do, and then people who have to do what they're told. So the people at the bottom take orders, and they receive not just orders, not just being told where to go and what to do, but they receive an order. They receive a system. They receive a whole idea about who they are and what their role in society is that is given to them, is not something that they develop for themselves. So he was very much in favor of the idea of people creating and co-creating that sense of meaning from their own interactions. And another very recent book came out in the last year called The Ordinal Society by Marion Foucault and Kieran Healy. They kind of apply that sort of analysis to computers, and they look at the ways in which computer systems provide order. They take the chaos of life, and they produce numbers and facts and figures and databases that kind of we use to understand what's going on around us. In fact, I was going to ask if we have any French speakers here, because in French, the word for computer is ordinateur, which means it gives order, it ordains things, in pretty much the same way that God ordains things. And so that idea that something being in the computer makes it real, that idea that the computer says what is real or says what should happen, is kind of built right into the word, at least in French. So how do we live in a world where we can co-create these orders ourselves? So naturally, this is where I transition into talking about Zupass again. So we have these three things that are kind of new and are kind of interesting, called Pod, GPC, and ZAPI. There's a QR code for the documentation site there. And Pod stands for Provable Object Data. So it's basically a data format, a very flexible data format. GPC stands for General Purpose Circuits, which is a flexible system for making ZK proofs. And ZAPI is a new thing that we've recently built that enables you to embed Zupass functionality directly into your own apps. So Pod lets you create your own data structures. You know, if we think of an order, sort of a system of understanding as being made up of structure, you know, ontology, what's real, and logic that tells you what you can do with those things, Pod lets you define the structure. So here we're defining a frog. If you've played Frog Crypto, you've interacted with this structure. And it tells you what's real in the world of frogs. It tells you what exists. But you can create these yourselves, so you can issue your own frogs. You can extend this. You can add a frog that has some extra attribute that other frogs don't have. You can verify the signatures on frogs, so anybody can issue them and verify, you know, have a list of maybe valid issuers that they would accept as real. So it's a very flexible thing that is under your control rather than being issued by a central authority. And then GPC lets you create your own logic. And this is where things start to get interesting, because the question of what does it mean to have a frog is determined by what you can do with it. And what you can do with it, at least in Zupass, is determined by what kind of proofs you can make. So if I can prove that I have a frog of a particular type, maybe in some space, in some community, that allows me to do something. If I can prove that I have 3 frogs, maybe that proves something else. If I can prove I have a frog and a ticket, maybe that has a different meaning. And these are kind of contrived examples, but you could imagine doing this with any kind of data type you like. Again, with Pod, you can make your own data, so you can kind of reinvent this system however you like. And then ZAPI lets you embed this directly into web applications. So this is this is cryptographic data and zero-knowledge proofs directly in the browser in something that looks like a basic standard ordinary web app. Again, you've probably already interacted with some of them while you were here. So Frog Crypto would be one. Meerkat would be another. So if you've submitted any Q&As during any of the talks, you will have interacted with an app that does this, and it uses pods, it uses GPC proofs, and it also gives you pods back for participating in that. There's a kind of cool one there. Shulgin Engineering, I think, is new. So that's, again, it's a community project. I think that just came out today, which lets you take 2 frogs, extract venom from them, and create a psychedelic substance. So again, the meaning of these things is in the hands of the developers. It's in the hands of the communities that want to kind of figure out what we can do with this stuff for themselves. So thank you very much for listening to me ramble about philosophy. As I say, if you want to learn more about how this stuff works on a technical level, we have a CLS tomorrow. We're very happy to see all of you there. We also have a documentation website which has a link to a Telegram group. If you want to come and talk to us in the Telegram group, please do. Thank you very much.
Thank you, Rob. Nice.